Hello, we are the 2025 Data Plus. Hello, we are the 2025 Data Plus team, working on data science for Durham Public Schools operations and planning. More specifically, we're working on building school siting models to help the school district predict where to add future capacity for middle, high, and elementary schools based on demand and population growth. The Durham County population grew by almost 6% within the last 5 years, and multiple high schools are operating well over capacity. This is not helped by the current boundaries, which do not optimize for the distance that students travel to their high school. With a more methodical boundary-making process, we can help students travel less distance to high school and also suggest new sites for Durham Public Schools to add capacity in the most needy areas.
Our framework is pretty simple. First, we projected future enrollments by combining current enrollment with projected student growth. We used residential developments in Durham County to project hotspots for future growth, and from there we developed two school siting models. To get precise numbers on student projection, we used DPS data on student generation rates by housing type and region. This matters because we expect certain developments, such as single-family homes, to have more school-aged children than, say, apartments or condos. We then took these rates and applied them to the residencies which are currently being constructed to get our future projections.
We built two siting models for our project. The first model utilizes mixed integer linear programming, a mathematical tool to optimize an objective function given some constraints. We seek to minimize the average distance students travel to school with constraints that all planning units must be assigned to school, schools must stay between 70 to 100% of capacity, and one new site may open. The primary challenge with this model was its runtime, often requiring over 12 hours to find a single site. To speed up this process, we built another model that draws boundaries similar to the linear programming model. Schools expand or contract their boundaries until they have captured, again, 70 to 100% of capacity. This model always generates compact and contiguous boundaries that are generally very similar to the linear programming model, although not necessarily globally optimal. This process allows us to efficiently score every new site, that is, all planning units as potential sites, as shown in Figure 7, based on the boundaries drawn by the model. Both models came to similar conclusions that additional capacity should be added downtown despite high projected population growth in southeast Durham. Furthermore, a new school downtown, along with more efficient boundaries, would alleviate overcrowding at Riverside High School and Jordan High School, the two southernmost high schools in Durham.
The significant conclusions that we drew from our models were first that even while using the maximum estimated population growth in southeast Durham, both of our models end up prioritizing adding student capacity downtown. As well, North Durham is never an optimal site in any situation, despite increased land availability and further distance from currently existing schools. Overall, siting schools near existing population centers in denser areas of Durham take precedence over providing a broad coverage of school sites across Durham County. In addition, the heuristic gravity model we independently developed aligns with the results of established linear optimization models while requiring less computational resources to find the same optimal sites. The next steps to take for this project have two different focuses. First, for considering real-life siting decisions, it's very important to ensure that models for school siting have the ability to consider local geographies to avoid splitting up existing communities. Being able to better implement the effects of local geographies can also assist in multiple aspects of the school siting process. For instance, a model can recommend an optimal site knowing it meets minimum acreage requirements or possesses adequate utilities access. Second, for further model development, we want to expand the linear programming of the existing models to a multi-objective model. This will allow for other important factors to be considered alongside distance, like socioeconomic and racial diversity. Our initial work with siting models was based around data from Durham Public High Schools. By incorporating and analyzing model results with middle school and elementary school data, similar overcrowding and capacity concerns can be addressed for all cohorts of Durham Public School students.